So, students, welcome back to the part 2 of lecture number 12. So, I gave you some introduction, okay, I will say some introduction of the machine learning model called decision tree or DT. Let us go forward further, what else we can know. So, as you know, this is a supervised learning technique and this can be used for approximating discrete valued target functions. Why discrete values? These are not continuous values target functions, right? Understand that? All of these things I told you, fact features, none of these actually are continuous valued target functions. They are all discrete valued target functions. Remember this. And each tree is composed of two important entities, leaves and decision nodes, right? You can see that leaves and decision nodes. So, you have a root, then you have internal nodes, then you have a leaf node, right? And so, decisions are made on the internal nodes, remember that. So, decisions are basically take place where the data are split into two parts, yes or no, correct, that is what we have done. So, now let us take another example. Let us say I have this data in front of you, right. You have outlook, sunny, overcast, rainy, right. Temperatures can be hot, mild or cool, humidity can be high or normal, wind can be weak, strong, and you have to decide whether you will play tennis or not, right. So, you see here there are 14 days of data, there are 4 features, outlook, temperature, humidity and wind, right, and you need to decide whether to play or not tennis on Saturday, correct. How will you make it? See, each input has 4 categorical features, I told you outlook, temperature, humidity, wind, speed. The binary classification problem, play yes or no, either you play or you do not play. So, what do? You have to construct a decision tree. How do you do that? Very simple, very simple, you do yourself. Okay. First you take this data and do yourself, analyze that. See, so therefore, I have made 3 outlooks, correct. The 3 outlooks, right, sunny, overcast, rainy. You can clearly say outlook is my root, what, root node, right, outlook is my root node. So, I can have 3 situations, sunny, rainy, overcast. If it is overcast, its decision is always yes, we play. Have you seen that in the chart? Let us go back, overcast, yes, right, overcast, yes, overcast, yes, overcast, yes, always. So, it does not matter overcast, when it is overcast, when it comes clouds, cloud cover, whether temperature is hot or cold, humidity is high or low, wind speed is heavy or strong, does not matter, because sun is not there, you always like to play. So, that is why when it is overcast, it is always yes. So, this is your leaf node, everything ends there, right. If it is sunny, then the 2 factors come into picture, one is called humidity. If humidity is high, you do not play, because you are going to sweat, right. Humidity is normal, then decision is yes, correct. So, if you go back this branch, outlook sunny, humidity is normal, answer is yes. So, you can see these are discrete valued functions, right, yes or no, binaries. Okay. Now, if it is rainy, then you have to consider rain can be always with wind, right. Obviously, overcast condition can also have winds, but does not matter, but rain can be always with rain with wind speed. If wind speed is high, obviously you do not play, because it is too difficult to play when wind speed is very high, but when wind speed is weak, then only decision is yes. So, you see that whole table data, this data, it does not matter, there are only 14 days, you can have even hundreds of days of data, 1 year data, 365 days data, you can put it in this condition, it will work, right. So, it is very easy to reason. So, now once this typical Saturday morning, when you are at home, when you have free time and you look at the weather and you decide very easily. So, that is what is called a decision trees, right. So, and you understood that decision tree actually is nothing but allow you to make the tree like structure, hierarchical structures I told you, where we can make decisions. Okay. Hierarchical tree like structures which consist of root node, branch, internal node and leaf node, right. So, internal node is where the decisions are made, correct. See, leaf node is where the decisions are frozen. The tree, every tree has a root, trunk, branches and leaves, right. I am not talking about flowers and fruits, forget about it, but this is what is the structure of a tree, right. You have a root followed by a branch and then you have a leaf. This is exactly what doing that, right. So, you are basically using same kind of structure, that is why it is called a tree, and we are making decisions at each internal node, or we are basically splitting data at each internal node. Remember this, we are splitting data at each internal node. That is exactly what we are doing here, and hence our idea is what? Our idea is to classify things, and this is the best way of classifying as aspects. Well, I remember I can go back to this table, and we have already made use this table for Bayesian algorithm also, Bayesian classification problem also, right. We can always calculate probability of each of these things and do that. Please go back to my lecture, very interesting algorithm. So, decision tree is another way of looking at it, but hope you will understand decision tree is much simpler and very easy to understand method. Okay. So, this is very fundamental, right. Please look at it. So, I again write down on the blackboard, I will go back and show you how things can happen. So, internal nodes is what represents the internal nodes represents what? It represents what it represents? Please remember, it represents attribute, it provides attribute test or feature test. Feature and attribute is both are used in machine learning, feature or attribute test, and this is where we split the data. Okay. We split data, correct. That is what is done in internal node, remember this. So, this is a very important part. So, root is what? Root. Remember root, what does it do? It basically it does it takes the basic feature or the main feature, and this is nothing but a starting point of the tree. And then you have also branch. Tree like structure, it is a branch. This branches represent attribute values, feature values actually, feature values. Is it not? If age is more than 30, say 30 is the value. Okay. So, this is basically done like this, right. That is why the branches comes out. So, there is a value, then value differentiate the data into two parts, and the last thing is leaf node, right. Leaf node is what? Everything ends. So, what is happening at the leaf node? Everything ends there, final decisions, right. Or predictions. Correct. That is what is done. So, remember these things. So, therefore, if I have to put a chart, which I can do it very easily here, if I have to write a chart wise, on the right side here you have some space. So, dt looks like this. You have a root node. Am I clear? Then you have branches like this on the root nodes. Here you make decisions. write big way, otherwise it will not be seen properly. Am I clear? Decisions are made, then you can go to leaf node. Okay. And similarly here also you can branch it again like a decision made. Okay. You can have further branches possible, where you can have decision made. That is what we did in the last example, and then you have leaf node. This is how a tree will follow. So, hope you understand that how the tree structures is following. So, some people say it has two important features. One is at the root, you have one of these three, leaf and the node, right. Leaf is where everything ends, and this nodes where decisions are made, right, or where the data are split. So, we can always call wherever decisions are made as a node, right. Many people say that also. This is a node and its decisions are made, data split, and leaf is where the tree ends or the predictions are done or final decisions are done. Okay. So, each branch you can clearly see at each branch it descends from the root. So, all the branches will descend from the root. You cannot have you cannot start the whole tree without a root node, impossible. Okay. Root node is the basic point to start the decision tree. Am I clear? And each node is a basically specifies a test. The string specifies a test whether it is going to be divided into two data or not. So, there are two important algorithms which is schools. One is called ID3. 3 is version 3. ID is known as a iterative dichromatizer. Obviously, you can understand this is an iterative process. Dichromatizer. Okay, remember this. It's not dichromatizer, dichromatizers, EID. And second one is called cut. Cut is easy to remember. You understand what is classification and regression tree. Classification. These are all available in Python, and okay. These two functions are available in the Python libraries. You can use it directly through that. So, these are functions which are used for classification in decision tree structures. The last thing which I am going to tell you today lecture is, what is the way you can split the data? What is the, how you can make a decisions? Is there any factor which we can calculate, or you can find out, or you can make some estimation before you decide? Is there any factor? Answer is yes. There are two important factors which are there. One is called entropy. Okay. second is called there are 3 actually, not 2. Let me write down that. So, you will calculate these factors every time you split the data and create a descent tree, right. Let us keep the descent tree alive here and we can do all these things. So, there are 3 factors I told you. One is called entropy, factors to decide data splitting. Okay. First is called entropy. Second is called information gain. Is called IG actually in machine learning literature, and third is called Gini index. GI. Some people call Gini, some people call Gini, does not matter, you should understand that. So, let us talk about each of these. So, entropy is what? It is basically, okay, I have to remove each of this to discuss one by one. So, entropy, let us say you have a data set S, okay, and you basically split the data in, you split in X and Y to 2 categories, right, subcategories, correct, and number of elements here is Px, here it is called Py, okay. So, you have a data set S and you made some decisions, split the data into Px and Py, so that it becomes in X category and Y category. Am I clear? So, entropy S defined as like this. X, the small x is a subset of capital X, summation of Px log 2 Px. Please remember this is log 2, that is why you use a base 2. This is not log E or log 10, there are 3 different log, right, log 10 base, log E base, log 2 base. So, this is log 2. So, that means what? The entropy is nothing but sum it over Px log 2x, correct. So, if let me give an example, let us say if I take a data and divide into positive and negative parts, plus or minus, yes or no, sometimes become plus or minus, right, plus event, minus event, like you toss a coin, you have either head or tail. Similarly, so if you consider head as a plus event and tail as a negative event, you can write down like this. So, entropy of that is equal to minus P plus log of 2 P plus minus P minus log of 2 P minus. Okay. That is what sometimes write written as a sum. This minus is not there, sorry, sum minus P x log of 2 Px, right, where x is basically subset of big set, okay, sorry, subset of S, right, because big set is split into 2 sets, right, that is what it is. So, therefore, you can easily calculate the entropy, very easily you can calculate entropy. What you need to know is number of elements when you split the data, how many number of elements are present in X, how many number of elements are present in y, then you can calculate that, right. So, if you have to write in x and y terms, so I did not write that, it will be like this p x minus obviously log 2 p x minus p y log 2 p y, right. This is also okay. So, any of these things, so fundamentally this is what is the equation is of entropy. So, as you know, p x and p y are fractions. Why? Because suppose S has n number of elements, let us consider S has n number of elements and p x has small n 1 element and p y has n 2 elements. So, p x is what? Small p x is what? n 1 by capital N, small p y is what? n 2 by capital N, right. Am I clear? These are all fractions, remember, these are all fractions, n very large compared to n 1. So, therefore, or n 2, therefore, these are all fractions. So, when you take a log of a fraction, it becomes negative, and this negative and this negative will cancel, become positive, right. And this is obviously a multiplying factor, p x or p y is a multiplying factor of the log term. That is why equation is written like this. So, entropy is always going to be positive as usual. In material science also entropy is always positive, physics also entropy is always positive. So, therefore, this is how it is defined, and please remember that. So, you are going to calculate this entropy at every time you split the data. Every time you are splitting data, you are calculating the entropy. Why you are doing, how you are splitting data? You are splitting data into two parts, right. So, this is what is your maximum number of elements or total number of elements, you split into two parts. So, once you split two parts, then entropy should increase, right. Otherwise, you are not doing the splitting properly, or you are not making the divisions correctly. So, this is what you see, you have to calculate the entropy continuously for each time you split the data, and you must see that entropy must increase, right. It must not, I am sorry, entropy must decrease, not increase, sorry, entropy must decrease, okay, because you are splitting into two parts, here your values are much different, sorry, higher. So, therefore, these fractions will be lower, so therefore, entropy will keep on decreasing, right. So, this is you must make ensure when you split data from the root node to the leaf node, entropy must decrease, okay. So, this is about the entropy. So, let us talk about a little bit about information gain, okay, and this that will also be similar. I hope for material science student entropy will be much easier to understand, because we always learn about entropy of mixing, right. You remember entropy of mixing is in Boltzmann concept is what? Minus r log of, sorry, for a binary solution is minus r x a ln x a plus x p ln x p, right, in a binary solution, or you can write down as x a ln x a. These are actually E base, remember. So, what is the log we are using is base 2. So, 1 minus x p log of 1 minus x p, because x ray since x ray plus x p is equal to 1. So, this is how you can calculate entropy. Here also again x ray x p's are fractions. So, therefore, log will become negative, and then negative and negative will cancel, and the whole entropy of mixing will be positive. That is what is expected. So, similar kind of equations. So, if I have to write this also like this, okay, I can always write down r like this xi ln xi, right, where I can go to 1 to n. Am I clear? Same thing I am doing when I am doing entropy definition. This is I am doing like this, sum it over minus p x log of x 2, where x belongs to x, right. Am I clear? So, this will be p x, right, log, not log ln. So, fine, it's similar kind of equations, you must understand that. So, what is information gain then? So, information gain, right, the second factor. Many people call it IG, information gain IG in machine learning. Let us assume A is an attribute or feature, okay, and which is making set is getting split to create T, which is subset of S. So, root node, this is basically subset of root node, right. You have a data, everything is here, then you first you split into two parts. So, these are subset of this, right, that is what it is. So, S is split, create T subsets, and so therefore, we can write down PT is nothing but P capital T, not small t, is nothing but proportion of elements you understand, right. Element is number of available things in that particular subsets. Number of, so therefore, number of elements to, this is basically proportion, right, to total number of elements in S. Because you have split S into two sets, one is T, other maybe U or something, and then S, correct. This is what it is. Then we can write down IG is written like this, S so it is HS minus PT, sorry, we have PT, right, P is within bracket T. Okay. And what is HS? HS is the entropy. H is the entropy, right? That is the entropy. Am I clear? So, that means what? That means we can write down this is HS minus HS by A, because he has used, so it should be A, right. We have used A attribute. So, in the first example, I used A as an attribute, right, you remember. So, this attribute is used to split the data. So, from the total entropy, this has to be subtracted. Am I clear? Total entropy is subtracted, that is what is called information gain. Am I clear? This is very important, remember this, because information gain must increase, gain must increase as you move on. Please remember this, gain must increase as you move on, otherwise there is no advantage of splitting data. So, as I will tell you again, information gain is basically used to split data S or any set S into different parts, okay, and by using attribute A, some attribute A. The attribute is used to split the data, and when you do that, you calculate information gain, and that is how it is calculated according to this formula. So, once the information gain is positive, then you have done the job properly. If information gains become negative, that means your splitting of data are not perfect. Am I clear? So, let us stop here, because I have given you a lot of important information. In the next class again We will talk about these equations little bit before we move into what is known as a SVM or support vector machine. Next class we are going to talk support vector machine, but some at the beginning I will again talk about this formula as well. Also I will give you the Gini index, what is the Gini index, and taking an example I will show you how to calculate that. Okay, even we will show you, take an example of steel example I showed you, and so that you can calculate yourself. Thank you.